Application of derivatives. Okay. Then derivative, there are different thing. Now, the derivative as a rate of measure. Suppose y is equal to fx is a function of x. Here, which is independent variable and dependent variable? X is an independent variable and y is a dependent variable. As y increases, decreases, or then as x increases, decreases, y also that same thing with the relation. So there will be a function x. Let there is a small change in the change delta x in the independent variables. Okay. Then the corresponding change in the dependent variable y is equal to delta y. Y is equal to delta y. For as x increases, the y will also increase. Okay, I'll give you the example later. So, for small values, therefore, average change in y per unit change in x will be delta y by delta x, because delta y is dependent variable, increase in dependent variable. Okay. For small change in delta x, the average change in y, that is rate of change in y per unit change in x is limit delta x. It will be gradually small, limit delta x tends to 0 is delta y by delta x. This, since it is very small quantity, we can write dy dx. So dy dx is represent as rate of change in the measure of y. Okay. Now, can you give me an example of anything is increasing change? Suppose here there is a cost of petrol. Suppose daily life we are thinking of that. Cost of petrol. This is increasing. This is cost of petrol is increasing. So therefore, the quantity of petrol will be decreasing. This is cost of petrol. And this is quantity of petrol. Quantity of petrol. Quantity of petrol. Similarly, there are many things, like one is increasing, another is decreasing. One is increasing. Can you give me an example of one is increasing, another is increasing, the other function is also increasing? Come on. So the cost of one notebook is rupees 3. Then cost of 5 notebook is rupees 15. Now I increase that the cost 4. Cost of one notebook is 4. So 5 it will be 20. One is increasing, one is decreasing. So this is petrol. Okay. Similarly, I will be doing all the sums. Here, one is increasing. There are two ways. One is decreasing, another is increasing. One is decreasing, another is increasing. So this is quantity of petrol will be decreased. Okay. Now here we have got many examples. Suppose many examples, and I think all of you start thinking in daily life. Daily life, I have many things that one is increasing, another is decreasing, and one is increasing, the other one is also increasing. One is decreasing, the other one is also decreasing. So we have done. This is rate of measure. Rate of measure means per unit, change in per unit. So it is per dy dx by delta x by delta y by delta x is dy dx. Okay. Now therefore dy dx represent the change in the measure of y. That is represent the change of measure y. Now we will be doing the sums on it. Four by three pi r cube. 4 by 3 pi. Question number 1. A balloon which is always remains spherical. Generally it is not spherical, but when we send the satellite balloon on the satellite and all, they are all spherical mostly. Spherical has a variable diameter 3 by 2, 2x plus 3. Determine the rate of change in the volume with respect to x. Now, this is given diameter, okay? Therefore, answer 1, therefore radius of the balloon is equal to 3 by 4, half, it will be half 3 by 4, 2x plus 3 plus 3. Therefore, volume is volume of a spherical balloon is equal to 4 by 3, sphere is 4 by 3 pi r cube, what is r here? That is equal to 4 by 3 pi, r is 3 by 4, that is 3 by 4 into 3 by 4 into 2x plus of 3 whole cube. Therefore, dy dx that is differentiating with respect to x with respect to x, that is dy dx, dv dx, that is v is a volume is that pi r cube, v is equal to this dv dx. This is dv dx is equal to, now this is constant pi and it will be 4 by 3. First function is this, that is 4 by 3 and 2x plus of 3 whole square because and differentiating with respect to x also, that is into 4 by 3 into 2, differentiation of 2x is x only, 2x is x, okay, 2x is x, that is, and this is the constant, okay, so that is equal to pi that is square, 16 into 4, that is 20, 16 into 4, 64 divided by 3 square is 9, 9 threes are 27. 27 into 27x, 27x into 2x plus of 3 whole square. Therefore, dy dx, therefore rate of this is your answer. This is your answer. Okay. So, rate of change of the volume, spherical volume, that is V is equal to this. So, therefore, dV dx is differentiating with respect to x. What do I have? dV dx means differentiating. This is this. Pi is a constant. I will leave pi as it is. And this is a function, full function, and that is 4 by 3 to 2x plus of 3 whole square into 4 by 3x, 4 by 3 into, 2x into 2x into 2x. Now, x is to the power 1, that is 4 by 3 x is to the power 1 is equal to 1. Okay, 4 by 3, it is 4 by 3. This x will not happen. Here, 2 into x, that is equal to 128 pi by 27, 2x plus of 3 whole square. Yeah. Now, so after calculating, I get it is 9 by 16 into 3 into 2x plus 3 whole square into 2 is the differentiation of twice x, that is equal to 27, that is equal to 27, 2 to cancel, 27 by 8 into 2x plus of 3 whole square, so whole square, plus of 3 whole square per unit of x, per unit of x. This is the done.